So you guys, continuing, cosine theta is equal to cosine of negative theta, right? Because cosine is an even function, okay? Just remember that. So you guys, I'm just going to show you 2 times, okay? So first, let's try to prove that this is true, okay? So I'm going to say theta is equal to pi over 2. So how do we prove that? We're going to prove it using this, okay? So I'm going to say negative r is equal to 3 plus 2 cos, right? Using our function here. But instead of putting, remember that we're using this right here, right? So this means we're going to replace it with negative theta. And you know what happens here, you guys? Negative r equals 3. But you know that this is true with 2 cosine theta. But negative r and, well, these two are not equal. So we know it's not equivalent, okay? You guys, for time purposes, I'm going to speed it up a little bit. But you guys, you're going to have to show it using this too. I'll just show that one, okay? So you guys, pi over 2. So it's going to be r. Does it equal to 3 plus 2? Sorry, 2. You're going to use your cosine, trig identities too. Cosine pi minus theta, okay? We're going to try to prove that. If this is equivalent, then that means it is actually symmetric about the line theta equals pi over 2. So now I see here it's going to equal, remember, this has to simplify to this in order for it to be equal. I have to use subtraction trig identity here. Okay, difference, right? So it's going to be 3 plus 2 cosine theta, cosine pi, cosine theta, plus sine theta pi, and sine theta. Sorry, the bracket, okay? And you know what happens here, right? It's 3 plus 2. And isn't this cosine of pi is negative 1? And this is just cosine theta. And this is 0, so it goes away, okay? And now I get that this is equal to 3 minus 2 cosine theta, which is not equal. So I know I can conclude that this is not symmetric about the line pi over 2. Okay? So now I'm going to try to prove that it's actually, and it's true, you guys, it's actually not symmetric about the pole. It's actually symmetric about polar axis, and I'll show you that, okay? So make sure you stop the video if you didn't get that earlier. I'm going to erase that so I can write this nice and big. So I'm going to try it now. So it's not this, but I'm going to try to prove with this. So I say r is equal to, right, negative theta, right? Let's try that case first. Negative theta, so it's going to be 3 plus 2 cosine negative theta, okay? But we know that cosine is an even function, so we know it's going to be equal to 2 cos theta. Oh, it's already done! So we know that this is equivalent, right? Therefore, we can conclude that this one is symmetric respect to polar axis. So we can actually conclude that, okay? But you guys, that's not the point of this. We're just trying to use this when we're to help us graph. So let's actually graph this now here, okay? All right, so you guys, this amplitude is 2, but we know that this actually starts at 3. So this line here is y equals 3. Okay, look at the graph. All right, I've already graphed it. And you know that this period is, the period here is 2 pi. So this ends at 2 pi. This is pi. This is pi over 2. And this is 3 pi over 2. And you can see all your other coordinates here too. So you guys, this is your max, right? Isn't this your max, 0, 5? Let's see, okay, 0 and 5, that's your max. And your min is here too, so it's at pi, it's at positive 1. Because remember, the amplitude is 2 and it goes down 3, okay? Your amplitude is, you start at 3, your amplitude is 2, so it goes down 2, which means 1, okay? Now, pi over 2, we know it's 3. And isn't this our 0? Because now our new 0 line is here where it starts, because there was a vertical shift. Now, pi over 3, what you can do is you can plug it in here, because you know cosine of pi over 3 is half, times 2 is 1, plus 3 is 4, right? But if you don't want to, you can look here on this graph too. Pi over 3 is somewhere between here, and you know it's around here somewhere, okay? So you know how this graph is 3, 4, 5, 6, okay? So it's 4 here, so pi over 3 is somewhere here, okay? Pi over 3 is somewhere over here. All right, so you guys, we have these points. You can get these points real easily, okay? So you guys, let's plot this, okay? But remember, go in order, and I want to see your orientation, okay? So 0, 5, 0, I rotate nothing. So remember, this guy is your 0, this is your pi over 2, this is your pi, 3 pi over 2. 0, 5, 0, 1, 2, 3, 4, 5. Pi over 3, so this is pi over 6, pi over 3. Pi over 2 is 3. 1, 2, 3. And remember, you guys, I'm going to put an A here because that's what we graphed first, okay? Pi over 3, 4. So it's 4 is here. Whoa, whoa, this is really interesting, right? So you guys, you remember, it goes from here, B to C, okay? So what does this really look like? It sort of looks like this. Following this path, you guys, just kind of follow it, okay? Just kind of follow it. And if you can't see, you could always plug in another point between here. So try pi over 6. Try pi over 6 if you have to, okay? But I'm going to trace this. Okay? I'm going to trace this. And you guys, you're going to do a better job than me, but just put arrows here so choose to note that it's going in that direction, okay? Pi over 6, okay? And try plotting a couple more if you have to. Now, what you're going to do is this. Isn't this actually symmetric about the actual y-axis? Let's plot a couple more. Actually, let's plot a couple more, okay? 2 pi over 3. 2 pi over 3 is here. It's 2. So it goes from here to here. So let's put D here, okay? Pi over pi is 1. Pi is 1. So that means pi, right? We rotate pi. It's 1. Oh, so let's actually finish it. This is better. This is better. Okay, so it goes from here to here. But you guys, isn't this reflected about the polar axis? If I were to continue, all it would do is it would actually do the same thing. And it would go like that. Sorry, this is not exact. Okay, if I had more time on this video, I would actually keep plotting more points. And it would just do something like that. I don't really love that. Okay, it should be a little bit wider, okay? So you guys, these points are exactly reflected, okay? So like 3, 3. And this guy is here, right? This guy would go 2, so it's 2. Okay, this guy would be 4, so it's going to be here. Oh, sorry. This guy would be 4. No. 1, 2, 3. It'll be something like this, okay? But again, plot more points so you can see it better, okay, guys? All right. Because we know that it's symmetric about the polar axis, okay? All right. So you guys, generally speaking, the graph of r sine theta is going to be symmetric with theta equals pi over 2, and graph of g cosine theta is going to be symmetric with the respective polar axis. Just have that in mind, okay, as you're graphing. All right, but you guys, AC, A, B, C, D, and then this gets reflected this way, all right? All right, so we're going to try on one more, or a couple more, okay? Let's look at the next page. It's 1 minus 2 cosine theta, and I've already graphed this for you here. You see how it's becoming kind of repetitive? So you guys, I've already graphed it here. You know that it starts at 1, so this line actually is y equals, I'm sorry, no, not this line. This line is y equals 1, okay? Okay, and you know your amplitude is 2, but it starts at -2 first, so it's 0, 1. -1, okay? That's where it starts. That's your minimum, huh? So you guys, 1 minus 2 cosine theta, and let's write the symmetry here. It's cosine, so we know it's polar axis. R equals 3, that's our maximum, isn't it, you guys? This is R, and this is our theta. R equals 3 when it's what? Well, we know that this guy, the period, is 2 pi, right? So this guy is going to be pi, all right? So let's fill in the bill. R equals 3 when pi equals theta. So when theta equals pi, that's your max, right? And here's your little important critical points. Remember that? And R equals 0 when theta equals pi over 3. But it also hits these values here, right? So you guys, all those values are reflected here, all right? This is my A, B, C, D, E, F, G. And this is my minimum, okay? And this is my 0, right? My 0. And this is my maximum here, okay? Can you see that? Okay? So now, remember, everything after this is a reflection about the polar axis. So we don't need to finish if we don't want to, okay? All right, so let's try this. So you guys, 0, -1. So remember, this is 0, this is pi over 2, okay? And this is pi. This all repeats every time. 3 pi over 2 here. All right, so you guys, 0, -1. 0, you can rotate nothing, but you're going to go not this way, but backwards. So that's your A. Okay, let's go pi over 6. Pi over 6 is here, right? And it's going to be -0.373. So it's along this line, but it goes back this much, 0.73. All right, and that's your B. You see how it's mapping? Look at the path, okay? Pi over 3 is here, and it's 0, so it goes back here. So you see how it went, shoop, Okay, it twisted a little bit, huh? And pi over 2 is 1. What? It goes back, pi over 2, and it goes back to 1. So you know that this is going like this. You can still follow the pattern here. Let's actually trace this so far. So it's going in this way, okay? All right, and that's our D, okay? 2 pi over 3. 2 pi over 3 is here. And it's 2, so we're going to go 1, 2. Ooh, it goes up! And then F is 5 pi over 6. And it's 2.73. So you see how we're actually plotting all these points here onto a polar coordinate. 2.73, so you go 1, 2, and 7, 3. All right, and pi is going to be 3. Then that completes our one cycle. So it's going to be D, E, F, G. Follow this pattern, guys. So I'm going to go done. Okay, done. But you know for sure that everything else repeats. So here's what I do. So you see this guy, it reflects. This guy, it reflects. So it's going to go, okay? Just go down. And this guy comes back here. This guy gets reflected here. This guy stays here. This guy gets reflected here. So you see this pattern? Dot, 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 dot. It goes this way. And it looks like this. There's an inner circle here. Okay, there's an inner circle here, and that's the shape of that. Okay, can you guys see that? And later you're gonna see what that's called. Okay, so that's how that goes. Okay, and you can see how all these points are reflected directly. So this is gonna be like B prime, you know. This is your F prime. This is your E prime. Okay, and this is your D prime because these are all just reflected points. Okay, all right. Now this is getting kind of old, but I'm gonna do another example for you. Okay. Ready? Are you ready? Are you bored yet? Okay, so you guys, let's keep going. Yeah, this lesson would have taken quite a long time. Now here, the period is, I'll just explain this, is 2 pi over 3, okay? Now this one is really a tricky one, okay? Now watch this. When I graph this, this ends 2 pi over 3. It's actually a cosine, so we know it ends here. This is actually 2 pi over 3. This is pi over 3. And this is pi over 6, and this is 3 pi over 6, pi over 2, here. Because one period, right? Okay, and amplitude is 2, so it goes from 0, y equals 0, and it goes up 2 and down 2. And here's the completed table. Make sure you understand that. Stop the video. But let's graph this, okay, guys? Now, let's graph from here to here. That's why the darkened lines are here. Now, if I plot this, I go from 0 to 2. And it goes pi over 2. Pi over 2 is here. Root 2. But, you know, this is pi over 6, right? But this is about right here, right? Pi over 12 is about right here, right? And it's this point here. So it follows this pattern here. And that's why this is 0 to pi over 6. Now, that's from A to B, right? A, B, C, okay? Now, let's put D, E, F, G, H here. D, F, G, A, G, okay? Now, it says right here, pi over 4. Pi over 4 is here, right, guys? But it says negative root 2, so you're going to go back. So it's about this point. Pi over 3 is about right here. And what does it say? It's negative 2, so it goes negative 2. And that's why this goes from, now remember, we already have this portion from the first thing that we did, right? First from 0 to pi over 6. Now, if we do this, we actually go from here to here. So remember, it's following this pattern. Path, okay? Now this guy. So, but this portion here is actually from, this is from pi over 6 to pi over 3, okay? And this whole thing is from 0 to pi over 3. And let's go from here to here. Now, what happens here? It says 5 pi over 12, okay? 5 pi over 12. What's 5 pi over 12? It's, let's actually do the G first. That's maybe easier for you to see. Pi over 2 is 0, right? So it goes back. Remember, we're stuck here. And then 5 pi over 2 is about right here somewhere, right? And it's like about here, because negative root 2. And then it goes to 0. So it goes back. So that means, you remember how it's going like this? We had this already, and now we follow another path, and then we end up here. We're going to keep going, though, okay? We're going to keep going. If we plot more points, try plotting more points. If we do this, you guys, what happens is we get these coordinates here. So that's how this becomes here. And then what happens if we later further points? From 0 to 5 pi over 6, look at all this, it goes all the way down to 0. And then what happens if we keep on going further from, this is guys from 5 pi over 6 less than or equal to 0 to less than or equal to pi. What happens is this guy goes here, and then now this part comes about. So to complete our rows, you'll see how this is called a rows, okay? So I'm going to erase some of this so it doesn't confuse you, okay? But you guys, the arrows are important, okay? Because it tells me it goes from here, it went from here to here, and then it went from there to there. Now it's going to go from here to here, right? Because it had already been following this path, okay? And then for this one too, it started here, here, it went here, and then it went here, and then it went here. Now it's going to go this way because it's been following this pattern here, okay? And then it completes one cycle, one period, okay? Okay, let's go on to the last page. But the last page, we're almost pretty much done. So if you guys can look, these forms, look at the forms. It's going to tell you the shapes. This one is spelled wrong. It's lemniscates, okay? So you guys, it went from here. If you see these, you know this format because you have to circle. It gives you a lemniscate. You don't have to memorize the names, okay? Lemniscate if it's in this format, and you get this cool infinity-like sign. Limicons is what you've been seeing, okay? But when you see this form or this form, it gives you this depending on the A over B ratio. Okay, so I think we saw, this is like my necklace here, cardioid, huh? It's like a bean. It's a bean. I'll show you later, okay? Here's a convex, it's closed surface. It's dimpled if it's A over B is less between 1 and 2. Inner loop. And you're going to see all this on your homework. And it's a rose if you see this format here, and we just saw that. Rose, what you have to remember is it has n leaves if n is odd. And if n is 3, that means it has 3 leaves. If n is 5, that means it has 5 leaves. It has double the leaves because you can see how sine functions are reflected about the pi equals theta. So you can see how this one gets replicated here and this one gets replicated here. And therefore, it creates double the number of petals, okay? So now try these, okay? Try these. Try identifying what these are. Like, for example, what's this? Oh, it's a lemniscate. What's this? It's a rows of an even number, okay? So that's that. But you guys, I'm going to give you a little bit more homework, actually. It's 21 all the way through 35 odds, okay? Try graphing those onto your polar coordinates. All right, good luck. It's really hard, but I know you can do it. Fighting! Bye!